So, you've probably heard this term floating around, vibe coding. You know, the idea that a developer can just describe what they want and an AI spits out the code. It sounds pretty futuristic for sure, but it also opens up some really important questions about where software development is actually headed.
But let's cut through the hype. What does vibe coding really mean for those of us doing the actual day-to-day work of an engineer? Well, in this explainer, we're going to break down what this shift is truly all about.
Okay, first things first, we need a clear, grounded definition. This isn't science fiction. What we're really talking about is a pretty fundamental shift in the whole development process. It's a move away from the simple mechanics of typing code and toward the art of good judgment. At its heart, vibe coding is really just an intent-driven workflow. As a developer, your job is to describe the what and the why. You know, the intent, the desired behavior, and just as importantly, the constraints. The AI then handles the first pass at the how by generating the actual code for you to review.
This really shows you the new division of labor, right? The AI is a generation tool. It's there to create those first drafts, the boilerplate, the scaffolding. And what that does is it frees up the human, you, to operate at a higher level, to be the architect, the reviewer, and the final decision maker.
I think this is the perfect analogy. Think about it. You would never hand a critical system over to a junior engineer and just walk away, right? Of course not. You'd give them super clear requirements, and then you'd carefully review their work. It's the exact same discipline here. The AI is incredibly fast, but it just doesn't have the context or the judgment that you do.
And that brings us to maybe the most important point of this whole section. This is not no code. Not even close. In fact, your deep technical knowledge is more critical than ever. All you're doing is delegating the mechanical part, the typing, to a tool, which lets you focus on much bigger, higher-level problems.
Okay, so we've got the definition down. Now let's get practical. How does this actually look in a real workflow? Because understanding where this approach is a game changer and where it can be pretty risky is absolutely key.
This diagram just perfectly illustrates the real engineering loop. And I want you to notice something here. Generate code is just one small step in the cycle. The whole thing starts with you framing the intent, and it's bookended by human-led review, rigorous testing, and really thoughtful integration. This is a discipline, not a magic button.
So let's be pragmatic here. This approach works incredibly well for clearly defined problems, things like building CRUD apps, dashboards, or wiring up APIs. But it starts to get risky when you move into areas that require deep, nuanced context, like managing complex state, writing security-critical logic, or anything on a performance-critical path. The principle behind all this is actually pretty simple. The AI is at its best when you can give it crystal-clear constraints and when it can lean on well-established, known patterns. The more ambiguous or novel the problem, the more unpredictable and, frankly, unreliable the output is going to be.
Now, this is a concept that anyone building with AI needs to burn into their brain. A tiny chance of an error in a single step might not seem like a big deal, but when you start chaining those steps together, one after another, without a human reviewing and verifying each one, that probability of failure starts to compound, and it grows exponentially fast.
So, whenever you have a technological shift this big, it naturally leads to a reevaluation of skills. The value in what we do is moving away from just knowing syntax and moving towards deeply understanding systems.
So what skills are becoming more and more valuable? Well, things like system design, trade-off analysis, and the ability to quickly read and reason about code you've never seen before. Those are huge. And right alongside them are the skills of writing really clear constraints and prompts, and, of course, designing effective tests.
If you only take one thing away from this whole explainer, please let it be this. The bottleneck in software development is shifting. It's moving away from the physical act of typing code, and it's moving toward the cognitive act of deciding what good, correct, and maintainable code even looks like for a specific problem.
Now, to be super clear, this doesn't mean that knowing syntax is suddenly useless. Of course not. But what it does mean is that being the fastest typist on the team or having every single library method memorized, that's just not the competitive advantage it used to be. Those skills are becoming commoditized. This brings us up to the team level. How do we actually bring these incredibly powerful tools into our workflows without creating total chaos? The answer, in one word, is discipline. In fact, solid engineering fundamentals matter now more than ever before. The teams that will succeed with this are the ones who enforce really clear cycles of planning, generation, and review.
They're going to lean hard on test-driven development. They'll create shared patterns for how to work with the AI. And, most importantly, they will not, under any circumstances, abandon disciplined code review.
And this really is the crucial point. AI is a magnifier. For a disciplined team, it makes them faster, more effective. But for a team that's already cutting corners, well, it just magnifies their ability to produce bad, unmaintainable code at a terrifying speed. The cost of skipping the fundamentals has never been higher.
So let's bring all these threads together. What we're witnessing here isn't the replacement of programmers. It's a profound rebalancing of the skills and the focus of our entire profession.
You know, when you really stop and think about it, the hardest part of building great software was never really about getting the syntax right. It was always about the strategic decisions. What should we build? How should all the pieces fit together? And how do we anticipate what might go wrong?
And that is the absolute heart of this shift. AI is automating the mechanics, which lets us, the human developers, dedicate more of our time and our brainpower to architectural judgment and high-level problem solving. This isn't the end of programming, it's an evolution. It's a rebalancing.
So the question this leaves us with is a personal one. As the tools keep evolving, as the demands of the job continue to change, how are you going to adapt? How will you rebalance your own skills to thrive in this new era of software development?